Hi everyone, I'd like to welcome you to the next lecture in module CO452, Programming Concepts. Now, in this lecture, we're going to talk about the main method, user interfaces, and how to input data from the keyboard. So let's start with looking at the main method. And up until this point, we've been writing our programs in BlueJ, and we've also been running them in BlueJ. We've created objects of classes on the object bench, and we've called them methods. And this has been great for our basic programs and our simple programs when starting out, but now that we are starting to get a hang of the fundamentals and the basics of programming, we're starting to look at some more larger scale applications, and therefore we want to be able to code these applications so that they can run outside of the BlueJ environment. And that ultimately is the end goal. We want to be able to create our programs so that they can run independent of any IDE, any development coding environment. Okay, so in order to do that, we're going to need to code a main method, which is going to be the defined entry point for our Java programs. So rather than creating objects of our classes on the object bench in BlueJ, we're going to write a main method which will sit within a class, and the compiler will know to go to that main method and run the program. So let's have a look at it. Here it is, and notice here it's going to sit in a standalone class. In Java we have to do this. In C++ we can actually code the main function outside of a class. It can sit outside of a class, but in Java we do, and C# as well, we do have to locate the main method within a class. And it's usually not a good idea to locate it in a class that also has other information as well, like a student class or a product class or a course class, which we've done before, because we might want to share those classes between programs and between applications. So we don't really want to be starting new programs every time we refer to that class. So here we're just going to create a standalone class. It's called program, and it's going to have one method in it, and that is the main method. And we can tell it's the main method because it has the name main. And notice in there, that's where we create objects of classes, typically, and that's where we will then run key methods to initiate the program, called the main functionality of our systems and our applications. So there's a couple of key things we need to point out about the signature of the main method. The first of which is it is static. Now, this means that we don't need to create an object of this class program in order to call the main method. This is quite advantageous because then we don't then have to have something else before this main method, which then creates an object of this program class and then calls main explicitly. Instead, we define this to be the entry point so that no objects are required. The compiler knows to come in here, and it knows that this is going to be the first method which is going to be run. Okay, so if we are creating main methods even within BlueJ, we don't even need to create an object of the program class. We can call it directly through the class name. Okay, and we'll see an illustration of that. So static in contrast to dynamic methods, and these are implicitly dynamic methods. We don't actually write the keyword dynamic. Dynamic meaning that we need to create an object of a class in order to call the method on that object to change the data, the variables, the values for those variables through the methods of that object. And of course, each object has its own values for its variables, so therefore it's the same methods being called, but they affect different objects. They change the state of different objects, okay? Whereas something that is static, we can tell from the word, it implies that it's constant, okay? No object is required, no dynamic different set of objects. It's not going to vary from object to object. It's the same code. So we can just call it directly through the class. Okay, so another thing to point out about the main method is that it takes a parameter, or otherwise known as an argument. Okay, you can think of that as just a different word for the parameter passing in data principle. And if you remember back to our previous lecture where we talked about the pair of square brackets, the subscript operator, remember this is an array. And so here we have the capacity to pass in a string array of arguments, parameters. Okay, so we could pass data into this main method. When we compile the program, there are some manual ways of compiling programs in other IDEs, which will allow you then to pass data in when you run the program, call the main method, of course. So you could do that. We're not going to play around with that, but that is an option. You could do that. But unlike our other methods where we have to pass in the number of parameters required by the signature, the main method is the exception to that. We don't have to pass that in. And even in BlueJ, you'll see that it actually has a preset pair of braces defined for you, so you don't have to fill that pop-up dialog box in. Okay, so just for point that out, I think you are required to state it, even if you don't go on to pass things in to the main method in Java. In other languages, there's probably a little bit more flexibility there as to you might be able to leave the parameters empty for the main method or function, but in Java, you are required to state the string array of arguments here. You could change the name of args if you want to, but it does need to be a string array. Okay, so let's move on and have a look at how we call the main method. Okay, so in BlueJ, you would see the class view in the BlueJ window, and where you would typically right-click on the class, the orange boxes displayed in the simple class diagram, and then create an object. You call the constructor of the class and create an object, and then that appears on the object bench as a red oval, and then you can right-click on that and call methods. With calling the main method, you can just directly right-click on the class, and then in the list of options, you can select main and call that, and then that will execute the code in your main method, okay, which is where we can start the application. Okay, so hopefully that gives you a basic summary there of the main method, which will be required as we start to progress outside of BlueJ, and indeed the final apps within BlueJ will require you to use a main method, just so that you're prepared for when you do eventually move on to other environments outside of BlueJ. You'll know that you need to write the main method, because that is how the IDEs will compile your code, and then in order to start the application, in order to then execute the application outside of the IDE, it's going to first trigger the main method, which starts the program. Okay. So there we go, that's the main method. Let's follow that up by talking about user interfaces. Now, we are probably more used to GUIs, and indeed you can create GUIs, graphical user interfaces, in Java. It's a bit more of an involved process to do that, so we'll save that for another lecture. But regardless to say, what we want to do is we want to form some form of text-based user interface just to give us something different from manually calling the methods on the objects, or at least having to stick to the hard-coded invocation of objects in our demo classes, where we just predefine what methods are going to be called and what data is going to be passed in, and then every time we run the program, it has that information. So That's good if the information never changes, but of course, if we want a more dynamic program where users can interact with it, which we are used to doing and is really the purpose of software and applications, we want to allow our users to interact and type data in so that it changes the application. We will have a go at creating a text-based interface, just a simple menu, which displays a list of options, and then we can respond to that live in the moment. Okay, we don't have to predefine code, which is operated in a linear fashion. Instead, we can have a live interaction with our application and call certain methods only when we state that we want to call them. Okay, so we've mentioned already about the differences between GUI and UI. So GUI standing for Graphical User Interface. That is what we are more used to seeing. As I say, that's usually when we see forms and nicely decorated web pages. But here we're going to be sticking to a more simple version of an interface, which is just a menu of text. Okay, as I say, it is possible to do it in Java. It just requires use of other libraries. Okay, so we'll take it simple, we'll keep it simple for now, and just focused on a text-based menu. Okay, simulating a front end, of course, which we could then go on to decorate a bit later and have nice form elements on it. Okay, so here we go. Here's an example of what a text-based user interface may look like. So we just got a heading at the top there, and then displaying a list of options and as a menu, and then asking the user to select one of those options. And the way they select one of those options is they have to type something in on the keyboard, as indicated by the last line here. Please enter your choice. Which one of the above options do you want to perform? Okay, so in order to do that, we're going to need to take a look at how we input data. We've done a lot of work on outputting data to the screen, system.out.println in Java, but we haven't yet come to input. Okay, so let's do that now. Let's talk about how we can input data from the keyboard. Now, in Java, there is a class given to us, which is called the scanner class, and it exists elsewhere, so we have to import that. It's also in the utilities folder, so remember at the top of our classes, whenever we talked about packages, and particularly with the collections classes like ArrayList and LinkList, we had to import those, and also random as well. Random is another class we have to import. We have to do this here with the scanner. We have to provide a reference to say that we want to refer to the scanner class, and it's located in this directory. So remember, right at the top of your file, you're going to want to write import java.util.scanner, semicolon. Okay, and then we can instantiate the scanner object. And the only new thing here, we've covered how to create objects of classes, which hopefully you're familiar with by now. The only new thing here is the system.in parameter, which has been passed to the constructor of scanner. Now, this is just a reference to the input stream of Java, similar to the output stream, which is system.out. So we've looked at system.out before, which allows us to connect the software layer to the hardware layer, the actual display, so that we can actually see things on our screens. Here it's the other way around. We want to connect to the input stream so that we can get what we type in on our physical keys on our keyboard, the hardware, and get that into the software layer so that we can then respond to it. Okay, so previously we've gone from software to hardware with output. Now we're going from hardware to software so that we type in on the physical keyboard and that data is then translated from those keys into our software layer so that we can store that in our code, in our programs. Okay, so remember you just need to write that system.in, pass that to scanner, and then we create, in this example, we're creating an object of scanner, we called it reader, and then through that reader object, we can then call the next methods of the scanner class. Now we see two here. Next line will return a string. And getInt will return an integer. And then we also have, if we were to look at here, we see a portion of the scanner class, but if you were to go to the official documentation on Oracle, we've got a link down in the bottom right. If you were to go to that, you would see a long list of next methods like nextChar, nextBoolean, nextDouble, which all return the data that you type in on the keyboard as that data type. Okay, so they're mostly explicit except next line. Okay, that's anything that isn't an explicit reference to string, but that just returns the entire line until you press enter. Okay, so you can return then a mixture of characters and letters, and it returns all of it. Okay, so there you go, just showing you the scanner class there, and I think in the example so far we're probably going to make most of the next line and the next ints, so you should be okay with just those two, but of course if you need to use other data types, make sure you look those up on the scanner class documentation. Okay, so that is a process for typing something on the keyboard and then returning it as that data type so that that value can then be stored locally in a variable. And you'll see, going back to this slide here, that we've set up temporary variables to capture what is returned from that method, the next line method, which, by the way, will wait until you type something in and then press enter. So it actually pauses the execution of the program until you type something in and then press enter. It won't move on from there. Okay, so it is a good case of user interaction, though, because it does allow us to interact with our programs. Okay, so let's move on and have a look at validation now. And validation is going to become increasingly important as we are asking information for user information. Now, humans are great, but they do sometimes make mistakes. So we need to make sure that we guard against those mistakes. If they type something in the wrong data type, we want to capture that. We want to prevent the program from crashing, and vice versa. Sometimes they don't always enter things in the right format. For example, here we've got a case where we might not want to allow negative values, so we might want to prevent them from typing those in and storing them, and likewise we might want to mandate that the input can't be empty if there's a required field, for example. So validation is a way of checking the validity, or in other words, checking to see whether the input is valid, whether it adheres to syntax rules and the logic of the program. Okay, and there are consequences, particularly in the syntax rules, if we mix types, especially in Java, because remember it's a strongly typed language, so we're not allowed to mix types. Okay, sometimes implicit conversions can take place, but for example, a big error would be trying to store a string literal in an integer variable, which clearly it can't store letters in a data type which only allows for numbers and whole numbers at that. Okay, so you want to avoid doing that. Okay, so let's move on and have a look now at merging all these things together, so capturing input and also validation too. So what we could do is we could build a class which will create some methods to allow us to both capture things from the keyboard and also validate them at the same time. Okay, so here we see the start of creating a InputReader class, which is going to be given to you in your apps. And here you see that we're importing the scanner at the top, which we're required to do. And then we're creating a field, a variable of this class called reader, so of the scanner type. And then in the constructor, we then instantiate it, passing in system.in, remember? Okay, so that we can then reuse this reader object throughout our methods that we define to capture pieces of information. Okay, so let's have a look at our getString method that we're creating, and it's going to become a wrapper for processing the input and also validating it. And actually, as well, we are also outputting a prompt to the screen. So in order to give our users some guidance as to what information they should be typing in, we can pass in a prompt to this method, string prompt, and then notice that prompt is output in the line within the while statement here to the screen, so that the user first of all sees a prompt. So it might say, please enter a choice, or please enter a number, please enter your name. It would give you an example of what should be expected, what type of data as well. Okay, and then in the line underneath that, we call the next line methods. This is for the string. It's going to wait at that point for us to type something in, and then whatever we type in is returned as a string, and then stored in input line. Okay, and then we check to see whether input line has had something input into it. Okay, so this exclamation mark input line dot is empty is checking to see whether it is empty or not. Okay, so here if it is not empty, or rephrasing that, you could check to see whether is empty is false. You can say equals equals false. Here we're just using the not operator. If there is something there, in other words, then it must be valid, or at least it adheres to having something in it. Okay, and then we've just got a Boolean toggle that we set to be true, so that we can then get out of this while loop. Okay, so this validation part now comes in, because if the input is blank, this is just a simple check. We're mandating that this is a mandatory field. We can't, let this be blank. So if there is not something, if input line is empty, in other words, we then print out a message, and we don't allow the user to progress. We actually go back to the start of the loop, because we're looping whilst it's not valid, whilst it's empty, and we're going to repeat the process. We're going to ask them for the prompt again, please enter something in, and then try again. Okay, so we keep repeating until the input is not blank. All right, and then we return that. Okay, so this is a very basic form of validation, just checking to see whether it is not empty. Okay, there's lots of other checks that you could also apply. Here we're just modeling a form of validation. Okay, and likewise, we're going to do something similar for the getInt method too. This time we're just checking against negative values. So here we are doing something very similar. You've got a very similar format here, where we pass the prompt into the method getInt, throw it out to screen, ask the user for a number, and then call the nextInt method of the scanner class through the reader object, wait for something to be typed in, a number, attempt to store that in number, the integer variable defined in the method, and then we check to see whether the number is greater than 0 or not, and if it is, then it's great. If it's greater than 0, it's true. It's a valid input, and therefore we return it. Okay, but if it is less than 0, then we output that your input cannot be negative, and therefore we repeat the process. Okay, we ask them to type in a positive integer, and we keep repeating until it is positive. Okay, so that again, just a basic form of validation here, just to check the numbers being inputs. Okay, so you might want to extend that. You might want to check for other things too. It might need to fit between a particular range, perhaps. It might need to be a particular format of numbering. So just an example of how you could write some validation. Okay, but all going well, this would then allow you to type something in on the keyboard, store that in local variables, and then from there you can go back to the previous lecture where we talked about the string class, and you can apply some of the methods such as equals and contains to then check to see whether what you type in on the keyboard, especially if it's a string, matches some of the menu options, or at least one of the menu options here in this list. If we type in add, then we should expect to then run the add functionality. So we'd have to have some form of comparison to test whether we have typed in add. Okay, so we'll leave it there. That's a little introduction to the main method, user interfaces and inputs. If you apply all those things and take some of the methods from the string library and also for other data types as well, if you test them and compare them, that will then allow you to call particular functionality based upon your user entry. Okay, so I'll leave it there. Thanks very much for listening. Hope that was beneficial. I'll see you in the next lecture.